Hey folks, Adam Dupay here, and in this video we're going to be looking at the pwnable.kr challenge mistake. So this hopefully looks like should be an easy one, and it's only worth 1 point, so hopefully I don't get too stuck on this. And I actually haven't looked at this at all, so this is a brand new live hacking. So let's read the text. You always got to read the text. It says, "We all make mistakes." That is definitely true, pwnable.kr. We all make mistakes. Let's move on. Don't take this too seriously. No fancy hacking skill is required at all. Great. I don't feel like using fancy hacking skills. It says this task is based on a real event. Interesting. Shout out to DH Monkey. And the hint is operator priority. So this is an SSH level. So if we go in, we can see we have our mistake binary, which is set UID mistake pwn. We have our flag that's only readable by mistake pwn. Interesting, we have this password. I don't know what that is. Maybe that's something, maybe it's nothing, who knows. So I've got everything locally so I can play with it. So here looking at it, okay, great. So not too long, but for 1 point, that is interesting. Okay, so here we have our main, we have file descriptor, integer, open, home, mistake, password, read only, print an error if we cannot open it. It's telling us to do not brute force, then sleep for time 0 mod 20, interesting. So sleep for up to 20 seconds depending on the time. I believe sleep takes in a number of seconds. We can verify that really quickly. It should be 3. Sleep for a specified number of seconds. Great. Okay. So sleep for a specified number of seconds. Then character, password buffer, password length +1. So password length, these are pound defines at the top. Password length is 10. Then reads in the 10 bytes into the buffer. And then it creates a password buffer 2, input the password, reads in 10 bytes into password buffer 2. Then XORs are input. So interesting, we'll have to look at that. I mean, it looks maybe fairly straightforward. And then says if string compare password buffer 02, password underscore length. I said operator preference. Interesting. Okay. So it's seeing if we can guess the password. Let's briefly check out this XOR, taking an int 0 less than length, I++, SI, XOR'd with 1. Okay, so that should be easy. And then if string compare password buffer 2 with the password length, okay. Okay, the tricky thing that's standing out to me here is this sleep. So and obviously it's telling us not to brute force and it's doing this sleep. I wonder if we can maybe read from this process's file descriptor, although I don't know if you can actually do that, but that would be something to try. Home mistake password, read only 0400. Okay. Now, why don't we... So let's go to this machine. Let's SSH to it here too. SSH, this is mistake. They are all mistakes, my friend. Okay. So if we do mistake, then we do cat psaux grep mistake. Interesting. Cannot access proc. Okay. So So the proc file system is not, it's executable, so we can do proc self. Can we do that? Okay, good. So we can get, so we can't see all the process IDs, but let's see if I stop this. Okay, let's see. Okay, so this is actually, I think, pretty easy because it's going to read, so our input, it's getting our input from, so how can we make it, I think if we, let's see. Oh, but it's XORing our input, so we can't just, okay, so my first instinct was, well, this should be easy. Let's do mistake and then give it the input self, or proc self FD. I think it should be 3, so 0, 1, 2, the next one should be 3. Right, it can't do that, but okay, so fundamentally we have to know the password because the password is read-only, home mistake password. Do not brute force. System bin cat flag. All right, that's saying operator priority. So the other thing I'm thinking of is, well, if this was not a absolute address, so it didn't start with slash, we could actually try to play some games here, but I don't think we can. Let's do this. Let me look up bash how to, I want to know, how do I get the process ID? I think I can do this pretty easily. I can do mistake, ampersand, and it's telling me it's 3937. What if I cat proc FD3? Permission denied. Is that because I can't see this? Oh, interesting. Yeah, okay, I think the problem is because it's running as a setUID binary that I won't be able to mess with or see any of the file descriptors here. All right, okay, so go back here. Mistake. We all make mistakes. Let's move on. Don't take this too seriously. All right. How could that? Thanks, Siri, for that. Is there something we could play with string n comp? Close the file descriptor, return 0. There's no overflows. Yeah, I can't open password. I mean, we could put a password file in there. Do not brute force. Oh, maybe that sleep is just in there to make it so that you can't brute force it. Okay. So, read. Is there any way we can get read to somehow return less than? I mean, read is going to do best effort. and to read. Let's see, read attempts to read up to count bytes from file descriptor into the buffer starting at buff. On files that support seeking, commence at the current file offset. The file offset is incremented by the number of bytes read. If the current file offset is at or past the end of file, no bytes are read, and read returns 0. What if we give, could we open a link? No, I don't think that would work. If count is 0, read may detect the errors described below. In the absence of any errors, if read does not check for errors, or read with the count of 0 returns 0 and has no other effects. Okay, on success, the number of bytes is returned and the final position is advanced by this number. It is not an error if this number is smaller than the number of bytes requested. Yeah. I mean, so that's the interesting thing about read. It's always possible to return less. So it's just checking if it's less than 0, close it. And then scanf password underscore buff2. It's 1 point. It says no fancy hacking skills. Hint operator priority. What operator priority? Read only 0400. So what is the permissions on this? Okay, yeah, read only from mistake pwn. Mistake. Its owner is mistake. I can execute it. Okay, that makes sense. It's interesting. I may be stuck on this for a bit. This is, I guess, what happens when you do this live. All right, time 0. That just returns the current time. I believe that's the current Unix timestamp, but hey, let's make certain. Time returns the number of time in seconds since the epoch. Yeah, that's the Unix timestamp. Mod 20. And then character password buffer int length. Length isn't used anywhere. Close file descriptor, return 0. Character password buff 2. I've got to somehow get that password. Oh, FD is the return value, I see. So you could see that. Let's see, is there a read from that? Is there any way that these error clauses could be helpful? Input password, scanf, %10s into password buffer 2. So this is definitely passing the address there. Let's see, XORing input. Is it? It doesn't output anything, so I can't. I'm just trying to think if there's a way, maybe if I don't 0. If you do less. Let's see, but password buffer 2 is never output, so we don't even get the output of our own buffer after this XOR. This XOR key flips the last bit, so the interesting thing about this XOR is it's going to, let's say if we put, I don't know, 120 in. It's going to, okay, let's create an environment here where we can. Let's see, it's interesting. It's a 64-bit executable. Yeah, it just says wrong password. The other thing I was thinking of, is it possible to, the timing attack would be difficult because there's roughly a random time. I mean, you could probably guess it, but one way to do it would be to try to crack it byte by byte, but that seems way too involved for a 1-point challenge. But hey, maybe these points are all bad. So let's see, XORing the input. Would it leak? If I give it null. Wait, operator precedence. What does that mean? Operator maybe in the C code? Yes, I know not to brute force it. Okay, interesting. Maybe let's open this up in Hopper to see, look at this binary and see what it's, what it looks like. So operator preference could be a mismatch between what we think of as the C code and what actually gets compiled. So let's look up. We are in mistake. A mistake. Hopefully this won't be a mistake. Okay. So we have our handy dandy main function. That's right. So probably this should compile. I don't think there's been anything crazy. So this is the time that's probably been hard coded in. Read, if it's this, return this, otherwise this, puts this. Close, otherwise call a scanf that we want, and then XOR variable 10 with 0xa. Why is it A? Oh, 10, because we're doing 10. All right, let's look at this XOR. Okay. So variable 18. Okay, let's look at the C code. Int I for I equals 0, I less than length, I plus plus, S, so S is a character pointer, bracket I, XOR equal, XOR key, which is 1, XOR equals 1. Interesting, okay. I mean, this looks pretty straightforward. All right, you have the local variables. Yeah, I mean, here's the XOR with 1, moving the byte RDX into EDX, adding. If RAX is greater than or equal to that, break. Wait, var4 is equal to var4 plus. Oh, I wonder if operator preference means on the C code. So maybe we can make this fail somehow if open. Okay, let's go with that theory, and then let's click something. Not sure I got this split screen, but I'm not like it. Okay. let's look at main, and then let's, says a call to open. So the file. So I like making these strings because this is going to make this much easier to understand. All right, let's save this Hopper file. Hoppa. Okay. So what is actually happening? So it calls open, and it right shifts it 1F? Right. var 38. Okay, what's going on here? Call open, shift right EAX. What? Yeah, so we can already see this length is different. So length, file descriptor, password buffer. But how could I control that? I'm not entirely certain yet. Let's see, this is a read. Okay, I mean, let's look at these blocks, how they actually compiled. So, shift right 1F? Why is there a shift right? Interesting. And move EAX into variable. So, and actually, just to make this a little bit more handy, we know this is FD. So it's the file descriptor. Compare the file descriptor to 0 if the file descriptor is 0, then jump if they're equal. If it is equal to 0, okay, so it looks like the error is not here. This is the what we would think of this syntax. Oh, it must be this this less than 0 check. Interesting, by doing this shift right. I have to think about that, the semantics there, but can't open the password file. Call format, move 0, and this should be a jump to the end of the program. Yeah, so this just checks and does the stack check. Okay. So then do not brute force, call time, then do some stuff here, then call sleep, and then, so variable 30. So now what's the next thing that's going to happen? Oh, file descriptor. Right, we're going to call read. So this must be pw underscore buff. All right, this is the file descriptor, this is the buff, RCI. Yeah, so password buff goes into there. RCX goes to RSI. The number of bytes we're reading is 10. So then we call read. We test EAX, set G, move ZV, and then move EAX into, and this should be length. Compare. Yeah, I mean, that's this check. Compare 0. If it is, then jump over it. If it's not equal to 0. Okay. What's the man to read? I wonder if we can make read. Let's work on blocking. Let's see. I wonder if no, we can't read that file. Let's see, I wonder if there's a race condition where, I mean, it's a read-only file. Again, this X, if there's an error, this number is smaller than the number of bytes requested. This may happen, for example, because fewer bytes are actually available right now. On an error, -1 is returned, the error number is set properly. Okay, so let's see what happens if length oh, interesting. So move EAX. Is length ever used again? It looks like length is... It is not, but it is used in the result of this check, so the length is not really used. Okay. Well, let's see. We know from this that we need to create a file, and this should be pretty easy. We can just touch home mistake password. Let's see, chmod mistake touch home password. Oh, let's 10. All right, one thing that's gonna be super annoying is that sleep, so let's nop that out. So it's actually something I really like using Hopper for. So the idea is we want to just completely, basically, modify. We want to nop region. Modify nop region. So nop that, it's putting in a nop that is exactly the size we want. And then file, we should be able to produce new executable that has this. Mistake, no sleep. Wait, why is it? Why does it need that input? Let's see. 4, 5, 6, 7, 8, 9, 10. This should not work. It should tell me wrong password. It did say read error. That is interesting. Is that from Scanf? Oh, no, that's from here, from reading from that file. Huh. Okay. So now that we've been able to knock that out, let's debug it, and debug it, let's say, after that read call. I want to see what we can do here. Yeah, here's where I want to go. GDB, mistake, no sleep. Breakpoint at there. Run it. It should call read. So next instruction. See, why does it need a new line? FD. Oh. Okay, I think I see what's happening here. Super interesting. So this is something, so I just was hitting enter and like, why is it waiting for enter? And if we look at the registers here, we should be able to see. So actually I haven't completely dedicated to memory. I've done much more with x86 32-bit rather than 64-bit. So we can see the file descriptor should be in EDI. And if we print X EDI, we'll see that it's 0. So it's actually reading from us. Why is this happening? Okay, I think we got it here. So it's saying, okay, so this is exactly the problem. So it's saying the file descriptor is equal to open. So rather than having, it needs to have parentheses around this FD. If it was like this, the problem is that file descriptor is returning the result of open less than 0, which is 0. So it's actually not even reading the password file itself. Man, and we can actually, and it's actually hard to verify this on the server because we can't, wait, oh, not that. So if we strace this, we can see that it's writing do not force, and it's actually reading from standard input 0. So now the problem is if we tried to run it in strace here, we would see that we can't open the password file because when we run this in strace, strace runs as our user. So when we use strace or any of the ptrace trying to debug something, it runs as the mistake user, not as mistake pwn. So we can't read this password file. So we can't actually recreate this. And the sleep thing also throws you off a little bit. So this should be super easy then if, so it's reading from our input. So if we do mistake, it's going to say do not brute force. So the problem is this file descriptor is getting set to 0. So when it tries to read, it's going to read 10 bytes from file descriptor 0. So if I have my ASCII table, let's see, and I want this to be easy to type in, and so let's say 1 is 31, 31, and read will read a line, I believe, or just bytes. So is it going to look for, so if I do, let's see, hex 31, that should be 1. So if I do plus 1, that would be, or sorry, XOR 1. So it's actually not plus. So if I do 31 XOR 1, that's going to be equal to 30, which is a 0. Okay, so I can put in 10 ones and then 10 zeros, and I should be good. All right, so let's get that. Python-c print, let's see what I say, 10 plus 0 times 10. Man, it was as, I think it was as easy as they said. There we go. All right, so what happens? So when it called the first read, so it's reading from file descriptor 0, our input. We know it's reading 10 bytes into that buffer. So the 10 bytes it's going to read are 10 ones, and then it's going to read from Scanf, which also reads from standard input, another 10 bytes. So here we put in 10 zeros, and what does it do? It takes our input, which is a bunch of zeros, ASCII zeros, which are hex 30, it's going to XOR them 1, which sets the last bit, which sets them all equal to 1, which means our password is correct. There we go. Wow, operator priority. So this is actually a great example of why you I mean, I know it's kind of standard C techniques, but why doing assignment inside of this operator is a really terrible idea. So the safe way to do this would be set file descriptor and then compare that result to less than 0. Otherwise, here what's happening is this binding is tighter, so it's checking it with less than 0 and then it's setting it equal to file descriptor. So, all right, that was an awesome one that actually took longer than I thought, but hey, you know, just learned something interesting and new along the way. So hope you enjoyed this, and I'll talk to you later.